Next up in calculus, we're going to keep going with some differentiation. We're almost on to integration, but we're going to look at some implicit differentiation. So what does implicit differentiation mean? Well, up until this point, we've only been differentiating against one variable. We've had y equals x squared plus 4. And we have found dy by dx, nice and easy, 2x, for example. But life doesn't always work like this. As you can imagine, as you move further and further up in maths and science, physics, but maths and science, you end up with many variables acting at different times. So there's a couple of techniques that we use to deal with many variables. You have things like partial derivatives later on. But for now, we're just going to have a look at this key idea of implicit differentiation. And this allows us to take something that looks like this and differentiate it with respect to just one variable. So even though we've got two variables here, we can differentiate this and get our answer just in terms of one variable. Now, I feel like I said the word variable too many times there, but let me show you what I mean. If I have just 2x, and I want to differentiate that with respect to x, it's just 2. So that is d by dx, okay? If I had 2y, and I wanted to differentiate that, with respect to y, it would just be 2. But with respect to x, well, you might be looking at it and saying, well, there's no x variable. There's no x variable, can't I just consider it as 0? But the answer is no. What we would do is we would differentiate this, pretending, more or less, that y is x. So it would differentiate to 2. But just to prove that we know it's not an x, we're not that silly, we know that's a y, we need to add to it dy by dx. This kind of little clarifier saying, yeah, I know it's not actually x, but I'm going to do it anyway, and I'm just going to let you know at the end. And that is equal to the d by dx. Okay? This is differentiated with respect to x, which is what this little thing here means, right? This dy by dx means with respect to x. So I've acknowledged that, yeah, I've done it to y, but in reality, I mean x. And we can use this to differentiate some rather annoying looking functions. For example, what is the derivative, so d by dx, of xy? Well, again, up until this point, you might have looked at this and gone, well, y is a different variable, so the answer is just going to be y. Because if y was 2, and I had 2x, and it was just 2, so if it's yx, it's got to just be y, right? But the difference is, y is a variable. It is not a constant. If it was a constant, and we knew it was a constant, then fine, it's just y, as if it was 2 or 3. But we don't know that. All we know is it is a variable. It is changing, so we can't just do that. So I need to act as if these are both variables I'm interested with and add that clarifier. So that means I've got a function times by another function, and I need to use the product rule. There won't be many more videos that I write the product rule out explicitly. At some point I will expect us just to know it, but just in case we've forgotten, f of x times g of x differentiates into f prime of x g of x plus g prime of x f of x. So I'm going to say here that x is equal to f of x and y is equal to g of x, which looks absurd because there's no x value in the y, but it doesn't matter, I'm going to do it anyway. So if x is f of x, use a different colour, what is f prime of x? Well, the derivative of x is just 1 with respect to x. Remember, all of this is with respect to x. So then, what is g prime of x? Well, there's no x here, there's just a y. So I'm going to kind of mentally pretend that it's an x, but I need to add in that clarifier. So if I pretend that's an x, well, then that would just differentiate to 1, but I need to add in that clarifier, so it is 1 times by dy dx. The derivative of y with respect to x is just dy by dx. Another way to look at it, mathematicians will hate me for this, is if you have d by dx of y, because I'm a physicist, I'm a filthy physicist, I look at this and I say, well, that's not got anything to do with x, that's just a fraction. So it's d times y over dx. Don't think like that. Unless you're a physicist, then you're allowed. If you're a mathematician, ugh, awful. But sometimes it's a nice little way to have yourself think about it. Right, okay, so anyway, we've got all this planned out, so let's pop it into my formula. So f of x is x, g prime, let me start that again. I won't edit that out, that's fine. F prime of x is 1 times g of x is y, so 1 times y, plus g prime of x, which is dy by dx, times by f of x, which is x. So my differential becomes, get rid of that 1, y plus dy by dx of x. Okay, let's have a look at two examples, one of which looks slightly worse than this one, but this will be a nice one to play around with a little bit. First of all, something to notice, I've got an equal sign. Because I've got an equal sign, I'm going to want to have my answer being dy by dx equals something. Okay? I want to get an expression for dy by dx. The last example, all I found was d by dx. But here, I'm going to actually want to find the derivative of y with respect to x. Just slightly different wording. So, x squared plus 5y squared equals 14. Let's go ahead and do it. We're just adding terms so I can differentiate each of them individually. So x squared differentiated with respect to x is just 2x. 5y squared differentiated with respect to x. Remember, I'm going to pretend y is x for a second. So I'm going to differentiate it normally, bring the 2 down. So I get 10y, 2 minus 1 is 1, so just 10y. But remember, I've got to prove I'm not an idiot. I've got to prove I know that it's not actually an x, and I've got to add in my dy by dx. Equals, well, 14 differentiated is just going to be 0 because it's a number. So I get 2x plus 10y dy by dx equals 0. And again, because there's an equal sign in here, to tidy things up, I would like it to be dy by dx is equal to something. So I have a differentiated thing, and I know it's differentiated. So let's just do some rearranging. 10y dy by dx equals minus 2x. Divide both sides by 10y. dy by dx is minus 2x over 10y. Cancel the 2 and the 10 down to 1 over 5. Fine, I'll do it. I'm not lazy. Minus x over 5y. Right, now this ugly looking thing. Well, on both sides, I've got a function multiplied by another function. So I'm going to use the product rule twice. Not going to write it down this time. Hopefully it's starting to become ingrained in here. So, e to the xy. Let's just do the left-hand side first. So let's say that f of x is e to the x. So f prime of x is e to the x. And then g of x is y. And g prime of x is dy by dx. Okay, seen that earlier. Product rule, let's do f of x times g prime of x. So e to the x times dy by dx plus g of x, which is y, times f prime of x, which is e to the x. So that's my left-hand side taken care of. Right-hand side, I wonder if I can squeeze it over here. Let's use some different letters so I'm not getting confused. Let's say u of x is equal to x. So u prime of x is equal to 1. And then let's say v of x, I hate using these as well, I don't know why I'm doing it, but then let's say v of x is e to the y, and v prime of x is then also e to the y, adding our clarifier, that's dy by dx. So product rule here will be u of x, which is x, times v prime of x, which is e to the y, dy by dx, plus, hopefully you can see that down there, you should be able to, plus u prime of x, which is 1, times v of x, which is e to the y. Okay, so we've got this is equal to this. So how can I write this out best? I'm trying to use my space properly. E to the x dy by dx plus y e to the x equals x e to the y dy by dx, and I might have to just rub this out, I'm afraid. Luckily, you can go back in time and see it whenever you want. Unluckily, I've forgotten what was here. It would have been 1 times e to the y. There we go. Yeah, that's it. Nice. Right, and again, there's an equal sign. I'm going to want the differential equal to something. So let's get my dy by dx is on one side. So e to the x dy by dx. This starts probably looks brilliant, doesn't it? Anyway, minus x e to the y dy by dx equals e to the y, and then I'll minus that y e to the x from both sides. Pull out my dy by dx and get e to the x minus x e to the y equals e to the y minus y e to the x. And then if we just divide both sides by this thing here, which I can't do because I've run just about out of space, but if I just pop this on a denominator here, I will get my answer.